Hello? Hello, can you hear me?
Oh, hey, sorry. I need to figure out why my headset is not connected to the speaker.
I can hear you. Is it resolved now or not?
Sorry, could you say it again?
Yeah, I can hear you. I just wonder whether you still have the same issue.
There we go. I think I got my Bluetooth set up.
Okay.
Okay, hey. Um,
Mhm.
yeah,
Um.
so nice
Mhm.
to meet you.
Hi. Nice to meet you. So, we have a Google mock interview. Before doing that, could you set up like, describe your expectations on this interview?
Yeah, so I have an interview coming up
Uh huh.
on Thursday
Okay.
for a senior engineer job at Google. Um, and I believe the screening interview is coding in Google Docs. So
Right.
whatever we can do to get as close to that as we can, I'd appreciate. Um,
Sure. Yeah.
Also, just any tips that you can throw in along the way,
Sure.
I
We
appreciate
we
it.
can discuss it after. I mean, after our mock interview, we'll have about 20 minutes to discuss that.
Great.
Yeah. And for the so by the way, do you know your target level? Is it L4 or L5?
I believe it's an L5.
Okay. Okay. Cool. So so by the way, what's your program language?
I'm more comfortable in C sharp.
Okay. Sure. The reason I'm asking this is about like I probably need to change the description a little bit to for the program language, but it doesn't
Okay.
mean we need to use IDE. You already mentioned we only use Google Doc for Google interview. Yeah,
Okay.
I placed the question. Could you see whether it's clear enough to you?
Yeah. Okay. So find an interesting triplet. So given an integer array, an interesting triplet is where 0 is less than or equal to I, which is less than j and k, such that okay, so the indexes are in order and also the values are in order. So please
Right.
check whether array has at least one interesting triplet. Okay, so let's see. So the brute force way here is basically just check all the combinations, but then that ends up being about an n cubed
Right.
runtime. So the question here really is how do we do this efficiently?
Yes.
Um, so, hmm, trying to think, what would I do? So how would I handle this if I was just doing this by hand? So -2, and then move on until we get something bigger, and then something bigger here. But that's still just an n cubed algorithm, I think. Hmm. I think if I could use a hash map or something like that. Um, hmm. Maybe go through and store the number of values that are greater or less, or both. Hmm. Maybe just storing, if we go through this, we could have um, like a minimum after array, where if we go through this array backward, then the first one, it's just going to be, doesn't matter. So like infinite. And then -5, the minimum after that is 3. And then -1, the minimum after that is -5, I guess. And that doesn't, well, we might compare it to -1 also. So we need a negative, that's not going to work. We need the minimum that's going to be bigger.
Mm-hmm.
Hmm. So maybe we just need a max. The first one would be -infinity. Second one has to be 3 because that's all there is. And then for -1 we still have 3. And at -2, still looking at 3. So we could do that. So then that way we can get it down to an n-squared algorithm,
Okay.
where when when I is pointing at -2, and then we come through and we see -1 is bigger, and also 3 will come later, then we know for sure that there will be a triplet. So n-squared, that should work, because making this is order n. So then that doesn't increase on n-squared. What do you think? Is there going to be something better than n-squared?
Mm, max after ON. Uh, sure. I think n square is acceptable. We can. Uh, there's definitely algorithms that are better than n square, but we can optimize it later if we want.
Okay, sure. So, yeah. So if we have just a Boolean function here called has interesting triplet, and we're taking in this array, an integer array, then let's see. So if array length equals 0, or first, if the array is null, then return false. If the length is 0, then certainly return false, or just simply if it's less than 3. Um, Otherwise, we can say if I starting at 0, it's less than the length, and then increasing, and then j, which is starting after I, is less than the length, and increases. And then also, no, we don't need that. Okay, so first, before we go in there, we need to make the max after array. So an integer array max after equals I guess we might be able to go through, do this kind of thing twice, where we're looking for something less than the max the second time. But
Right.
so if we do the max after array, then, or maybe even just doing a minimum before, I don't know. Okay, so let's see. So this is going to be an integer array length. So new. And so we'll say all of the indexes in the array. We want to start at the end and then go backward. So I equals array one, and we want to say where it's greater than or equals 0, and then okay. So in this case, let's see. So we need some max that we hold for the. I guess we just check the array. So first off, if it's the first one, I guess we could just run that outside here. Let's see, so max after at the max position. We'll just set it to this itself, basically. Okay, so then if and we want to start the one. So then if this value is greater than one that came before, which is in this position, then we want to use that for the new max after. And otherwise, we can use self. Let's see if it'll look like that. So then, otherwise, max after is the array. Let me go here. This one. And this is max after. Okay. So then that should create this array like that. And then what we can do is I guess if we can go through again and we can find a position where the value at I like, so here is where this would be true. So the value at I is less than a second max after array value. And there's, and that would necessarily mean that also less than, which is also less than max after, then we can return true. So
sorry for interruption. First question, for the max after, does it include the current ARI or not? Basically, what's the definition of max after here?
So it would be basically, if you're looking forward, then it has the maximum number looking forward. So I feel like I'm just not going to end up using this last position. But then for like when we're looking here, we know that the maximum that's in this array that comes after is 3. And that remains true for all of these because 3 is the maximum number overall.
So for let me change the array. Just want to make it clear, right? So if it's something like that, what's the max after value in line 31? Yeah.
So here, this would start. We can just put self in there, and here's where the real work comes in. So here, it would be looking here and say, what's the max? And say -3. And then here, it would look here and say, what's the max? And say 5. And here, it would look at -1 or 5. And the max is 5.
Okay. Basically in the 0, 1, 2 in the index 2, right? You don't put 5 there. You basically it doesn't include this index, right? It's just really after that, right?
Right.
Okay.
Right.
Okay. Then I understand. Okay.
Right. So it's like a post kind of array rather than a prefix. So then what we could use here, I guess this array would return a false. But if we wanted to make that second one, say comma x and x. Here, I guess we would just fill in with -3 again. And here we would say, what is a number that's less than this, and is one of these numbers. So I don't know, I guess it might make sense to use like a negative infinity here. And then, so is there something what's the, if this changes, we need to change this too. What is less than this? It's the max. Maximum or less than the true max. So the second highest number that comes later. So then here basically is infinity again because we're not deep enough. So then here we have a new max. So we need something that's less than this, but the maximum that's less than those is one of these. So it would be -3. And we'd have to make sure that it also comes after this one. Because in this case, the algorithm that I was thinking would give an incorrect answer. -3, or no, this is less. If this were 3, this would be an incorrect answer. -1, 3, and 5 looks like a good triplet, but it's out of order. It would be out of order. So yeah, we need what comes before.
So what are you trying to target? You are trying to target like n square or linear?
Trying to, yeah, linear. So I'm trying
Okay.
for order n algorithm here, where we would go through the array 3 times, or maybe twice.
Sure.
And then sounds what?
Sounds good to me.
Okay, so then I guess when this changes, when this value here, then we have to start over. So it would be like -infinity. So that we're keeping track of what's less than this. What is the maximum that's less than that? So then as we continue on here, we can say, okay, so 5 build the max, -5 is equal, so we've got to continue and say -infinity is less than that. So because this ends up being -infinity at the end, then this one fails. Let's see if that works up here. So we have -infinity for the first two, and then with this one, since I ended up there, this one, since this equals this, and we're just carrying on -infinity. So we're gonna have to check actual value. No, this one should work. Okay, so here, this third one, saying, okay, so we need, is there something that's less than -3, greater than this, in here? And there is, so we say -5. But that fails this check if -1 is less than -5. So we continue. So then here, say here's 3, and here's -5. So is this one less than 3? Yes. Is it greater than -5? Yes. Put that here. And then we check, is -2 less than -1? Yes. And so that means that this is the triplet. Okay, so I think this should work. So we've already got this array. So now I think I've got the algorithm down for the second one. So let's go through again and create a max factor 2 array. Okay, so here we want this to be integer.min value. And then, so max factor 2. So we already know that the total length is at least 3, so we can go ahead and address the last two as minimum number. And then for this, what we were looking at is if the array value at I plus 1 is less than the max after value of I plus 1, and if it's greater than the max after 2 value of I plus 1. Then say max after 2 and I equals the array value. I, yeah, because we're looking at what comes after. So I plus 1. So then, if that changes, then we also need to check if we have the triplet. So if the array at I and max 2, and we already know that max after 2 is less than max after, so we don't have to check that one. Just say return true.
Max after 2.
Right, so this is the second highest number that follows. So if that fails, and I believe we just copy the number. So here, so here, for example, this was not less than this. 5 was not less than the max after value, so we just copied negative infinity. And then here, -1 was less than 5, and greater than negative infinity, so this should be -1. And that still fails the check of 2 versus -1.
Sorry, question here for the other max after 2. Do you mean to why in line 61 why you loop the arrays in this order? So why is uh in the like natural order instead of reverse order here? And also I plus 1 might be out of range, right?
So yeah, we need this to start at -3. Similar to how this one started at -2, because we're already taking care of these two.
Even like this, I mean the boundary is one question. The other problem is like if you loop in this order, how okay, you just revert.
And we have to go backward through it. At least that's the way that I was doing the algorithm.
If
Um,
I plus 1,
yeah.
if I plus 1 is larger than max after 2, I plus 1 is smaller than. Basically, what are the three numbers? So max after 2 and max after which one is smaller?
Here,
Mm.
manually comment these out. So here, so
Mm-hmm.
for example, we're looking at this position. So array at I plus 1 is -5. Is that less than max after of 3? And it is. And then is -5 also greater than -infinity? And it is. So then we use the array value for the current position, max after 2. That's what this is doing.
Uh, I mean, could you define max after 2? Like in line 67, I add a line like I add a comment like max after I. Basically, it is equals to maximum value of AR I plus 1, AR I plus 2 until AR n minus
Right.
1, right? And what's the definition of max after 2?
So max after 2 is a little more complicated. It needs to be, I think I have plug in my code where it's not resetting, but it needs to be the second highest, which comes for highest. So max after 2 of I is the maximum of these um, where I is less than source value of max after I. That makes sense?
Mm, yeah, I'm trying to understand this. So if AR I plus 1 is less than max after I plus 1, that means that is not the largest value. And if this value is also larger than, okay, I understand your point. If it's also larger than that one, this means this one is a new value. So max after 2.
seems like there could be a loophole here where, what if we had the array?
By the way, is your code complete? So basically the else part in line 79
No,
is empty, right? It's intentional to be empty, or it's not complete right now?
it's not complete yet.
Okay.
But if we had the array where it was 1, 2, 3, but then here was 5, so it would, yeah, so then the max after, so here clearly the answer is 1, 2, 3 would be the interesting triplet, right?
Right.
But max after would be 5, 3, 3. And max after 2 would be give infinity here. And then 2, so here when we get to 1, we should be finding that there is a valid triplet. Instead we find 1 is not less than negative infinity, and so it fails. So there's a loophole in catching. What could possibly be the next, the triplet here? So yeah, I'm not sure on if I can actually get an order n. It might be that I just need to do like a depth first approach where we create the max after array and then we go through and we say, okay, let's say I is the first value, and then, well, I guess we don't really need the depth first. We just go through and it's n squared. We say for I, we check, is j greater than I? Yes. Is max after greater than j, or the value at j? And so in this case, that would be a no. So then it continues on and says, is j, where it's pointing to 2, greater than I, where it's pointing to 1, and that's true, and the max after is greater than j. So that would work. I just feel like I can't nail down the order n algorithm. So yeah, instead of all of that, let's hit return instead of deleting it. So we would have to go through, we have to make a forward for loop. 0, I is less than array.length, I plus so I is, or j is starting after I. J is less than array.length, and j increases. We can get a little fancier with 2 and minus 1. So you can say, are you still there? There was some sort of connection issue.
Yes, I'm still there. Okay. I can hear you clearly.
You can say if the array at I is less than the array at j, and the array at j is less than max factor at j, printer. And then if we go through that whole thing without finding anything, then we return false.
Sure.
So that's pretty simple, but is there any way to optimize that?
And this is n squared, right?
Right. Yeah, because this is going through half of a square.
Mm-hmm. Right,
The
because
square
you
root
have
of
two loops
x
here.
and j. Right. Yeah. So is there n log n? Is there n order n algorithm?
Probably let's stop here because for for a real interview, the effective coding time is more or less the same as this one. Like we will have
Mm-hmm.
like first 2 or 3 minutes for briefly introduction, and the last 2 or 3 minutes you probably can ask the interviewer questions.
Mm-hmm.
Yeah, I mean as a real interview. Uh, so
Right.
I think you already have the basic idea, but what you gave like the max after two is very difficult to maintain, right?
Yeah. It's
Yeah, I mean why not do it in another another direction like uh since you have max after, why not create like a mean before, and it's similar like
that's a
the
good idea.
minimal
And then just
value
go
of
through.
the minimal
Yeah, and then
value
we
of
can just
this
go
one,
through and check. Oh,
and
yes.
what you need to check is like right
Yeah. Okay.
because
So yeah, if we have min before, and then all we have to do is check. Okay, like we can't start at the first one, but we can check at 5. Is the min before less? Yes. Is the max after more? No. But then here is the min before less? Yes. Is max after more? Yes. That just works.
basically when you give me the when you give the max after solution, it's very, I mean it's very fast. I think it's probably only 5 or 10 minutes, and then when you wrote max after two, I thought the I mean the definition might be just the mean before, it must be just a different name, and when you really write the code, I think I think it's very difficult to maintain that. I thought you were going to the way like to maintain a mean before as well, and at that
Mm-hmm.
time it's very difficult to give you hints like if I told you if I told you like just to give a mean before, it's just like to tell you the solution because the idea is exactly the same, right? The same as max after.
Right. Yeah.
Hmm. I'm okay to the n squared solution. For this question, our setup is like for n squared solution and linear solution, and probably this will. I mean, this is only kind of initial rating. It doesn't mean the final rating. Like this is
Mm-hmm.
probably a higher. It also depends on like the time, right? The code style, so there are also other factors, but the initial rating might be like higher and weak higher here. And if you solve this question, we probably give you another question. It may relate it to this one like a follow up, and it may be a new question. Basically, there might be another question to decide we, to try to raise the bar, like to decide whether we can give you a higher rating, like strong higher or leaning strong higher, whatever.
Mm-hmm.
Yeah, and
Yeah.
let me think about it. Yeah, do you want to discuss the solutions for this question? Indeed, it has a very simple uh linear complexity solution with constant space.
Hmm. With constant space.
Right. We don't
I'm
need
trying to think.
the arrays.
Trying to think because if well,
If I think
I guess.
I can hint you like there's a I think you already know the DP, the dynamic program algorithm of LRS, which is the longest increasing subsequence problem. And for this question, this is classical dynamic programming.
Mm-hmm.
Dynamic programming
So
algorithm.
I'm thinking if we would start at the first one, say, okay, now we have that's the min before, and we start the last one, we say that's max after, and so like that would be just two variables, not arrays, and then we go to the next one, and we say, okay, that's
You can do something like that, but that one it might not be two variables. You still need at least one array. I mean, only one of them can be a variable because you need to get the two
okay.
values at the same time. So you cannot. I mean, one of them can be updated during the loop, but not the other one because you cannot get the two values at the same time.
Yeah, I was thinking you said a constant space, which would mean no
I can give you some hints
no
if
like
you want.
arrays of length n anyway.
If you want, you
And,
can search online, or I can give you the solution directly. Depends on your decision. So for the linear time constant space solution, it's derived from the n log n solution for dynamic program for RIS question, which is calculate the length of the longest increasing subsequence. But our question is very special. Like we only need subsequence of length 3, and the n log n solution is basically the log n part is the log length or length of the increasing subsequence. But since our subsequence length is only 3 or less than 3, so the log part is indeed a constant. That's the reason we have another linear time solution, and this solution only saves the last element of the subsequence
okay.
of length 1 and 2. So we only save two variables. Basically, we only save the last element. Uh, yeah, that's the reason we can have a constant space uh, linear time solution. If you want, I can give you more details, or otherwise you can search it online. Try to understand the n log n solution for the LIS problem.
Okay. Yeah. I'll look into it.
Okay.
I'm sure
Then we can discuss other things. So, do you have questions to ask me?
um, so you said this would probably be good enough to get through the screen, right?
Yes.
So would it? What about like the actual interview? And um, also, do you think dynamic programming make up a high percentage of like these interview questions from Google?
Yes. Based on my experience, I think uh, these three categories are very popular in Google interview. Binary search. Typically, I seldom select this kind of category because this is kind of simple. And the second category is DP, which is dynamic programming. The third category is graph. The last two categories are very wide, right? So everything can be DP, everything can be graph. And I think for DP it's kind of very tricky. But if you, uh, I mean, if you understand that the code is very short, and on the other hand,
Yeah.
for the graph, typically the question itself is very straightforward, uh, but the implementation might be longer than a DP question. So typically, if you want to uh, evaluate the algorithm or data structure ability, typically we use a DP question. And if we want to evaluate the code or the implementation ability, we use a graph question. So these three categories are very popular in Google interview based on my experience.
Okay.
Hmm.
Yeah, that's good to know. I think dynamic programming might be my weakest subject in there, so
Hmm.
I need to practice that.
Yeah, somebody told me like Yesterday I talked to a interviewee who told me that I was not very strong, or I was not like I was weak on the array category, on the array questions. And I think what the interviewee means might be dynamic programming. While I talk with him, like it seems that everything can be array. The array is more wider than dynamic programming, and yeah, it's very difficult to define a category of arrays. The array is just a we we probably cannot even call that as a data structure, right? The array is just a built-in type, so it's very difficult to define like which question is related to array or not. At least it should contain all the dynamic programming questions. It may even include the graph questions because typically we use two-dimensional array, right? We use linked list or whatever. So yeah, array is very wide range. So I think what the interviewee means might be just a dynamic programming or a more wider
Mm-hmm.
category. Yeah. So, any other questions?
Um, I don't know. I think I'm pretty good. I mean, I know I need to work on my systems design, but that's outside of the
Yeah,
scope of this interview.
yeah. I think that's the uh special part of L5, right? For L5, we have system design interview.
Mm-hmm. Yeah.
Yeah. If you
Yeah.
don't have
I think as
another
far as
question.
coding goes, I'm good to go.
Mhm.
Thank you for
Mhm.
your help.
Thank you. No problem.